Right, so we're back with another video. 3D printers running in the background making noise. Working on the TA-4650, printing more RCA holders. So that's going to be a thing in the background. We're going to be working on the power supply board. I've got the ultrasonic cleaner washed out and topped up again. We're going to be cleaning this board, rebuilding it from the ground up, getting rid of all this lacquer. This is going to be a complete rebuild. I don't think anything is staying other than these ceramic capacitors. And yeah, so this is going to be quite the transformation. So let's get started and see what we get done in this video. All right, quick bit of housekeeping before we get started on why I'm doing things, and I'm sure there'll be a lot of questions, a lot of people arguing why you're doing that. I'm just rebuilding this board from the ground up. A lot of components will be fine. I'm just changing them because I can get everything and do it all at once. These diodes are obviously going to be perfect, but I'm replacing them anyway with new types. All the capacitors are getting changed. All the transistors are getting changed. Apparently, these 1124s can be problematic, so definitely get rid of those. I'm changing all the resistors because why not? I'm in here. Power diodes are getting changed to just general purpose diodes. The capacitors, the 100 volt ones, are being uprated beyond 100 volts because the rail voltage is like 97 volts, and that is too close for comfort for me. So at least 160 volts, could even be higher. It depends on what I was able to substitute. The only thing to be aware of is this little guy in here, this 1T243 diode, which actually has 3 legs, is actually not a diode. It is a repurposed transistor, apparently. And I will put on a chart over the screen, which I was able to find after hours of research of dead links and things. And the batch number below that designates the Zener voltage for this package. They're not all the same. Depending on that batch number, it is a different Zener voltage. And apparently this one is 7.5 volts. But do not take what it says in the forums as gospel that they're all the same, because according to this chart, they are not the same. So I ordered that as is based on what I could see in the chart, and I hope it's accurate. But yeah, let's get started. The bottom's looking beautiful. Yeah, I know a lot of people say, oh, don't clean it until you've finished doing all the soldering, but I'm like, well, I want to get all the old crappy lacquer off so I don't have to breathe it in, and then I'll just give it a wash down when I'm finished. I'm not going to put all the new components in an ultrasonic cleaner because that's just not good for brand new components, but I'll just give it a wash down with IPA when I'm finished doing everything. Oh, one other thing I forgot to mention, a trap for people just starting out, and I fell for this a few times. Double check the polarity of all your capacitors and the silk screening before you start. Take photos because the silk screening can be wrong, so do not trust it. All right, so this board is all done. I don't really want to admit how long this took because it was a lot of work. It looks pretty straightforward, but it took a long time to substitute all the transistors and replace all the resistors. Just making sure I don't put anything in backwards, and I think I got it all right. We'll find out. Basically, every capacitor has been changed, every transistor has been changed, every resistor has been changed, every diode has been changed. These ceramic capacitors were about the only thing left. So new power diodes, all the general purpose diodes are changed. The carbon film resistors have been changed to Vichet metal films. The transistors have all been substituted. Some of them I had to do a bit of a leg swap around to get them to fit. A new trimmer resistor, new power resistor for the LED at the front, new main filter capacitors. This was a lot of work. I do like to change things up from project to project to try new things. These VZ Nichicon capacitors are all I used on this board, and I'm not really a fan of them. For the high voltage use, like at the 160 volt, and there's a 250 volt one hiding in there somewhere, I guess you don't really have a choice. For general purpose stuff, I would use a different series because I think the ESR is a bit too high on these VZ series. So yeah, this board is done. I'm going to throw it back in the chassis, and I guess we'll try powering it up with nothing connected and make sure this thing does not blow up. Almost forgot that 1T243 transistor repurposed as a Zener diode checked out on my tester as about 7.4 volts as a Zener. So I've replaced it with a 7.5 volt Zener diode, but you do need to pay attention again to that batch number or whatever that is, the 2647 below it, because I'm not sure if that does change board to board or series to series, but in this case 7.5 volt Zener. All right, so we now need to do the super tedious job of rewiring most of the RCAs except for this one here and moving it across to the new binding posts. Now, there's a few things that are interesting here, how the grounds are split between the left and right RCA connectors, but they still are joined together in one area. I'm not sure if there's some reasoning that I'm not understanding in regards to grounding loops with why Sony did this and why there are separate grounds running between each of the RCA plates, but I'm going to replicate it just in case. This is just going to be a time lapse. I can't do much more. It's a lot of work and I need to really focus on the amount of wiring I have to do here. So yeah, let's get started. So here is the finished results on the back panel. It looks absolutely stunning, looks way more modern. Yeah, I just want to look at the back of it now. I don't even want to look at the front of it anymore. But it was an absolute mountain of work to do this. I don't recommend people attempting this unless you're really OCD like I am, because it just took a stupid amount of time. Yeah, it's pretty crazy. So I'm going to check the voltages on the power supply, same as what I did when I first powered this thing up. I'm going to throw the power amp module back in, then we're going to chuck it on the distortion analyzer and just get another baseline on where we're sitting at the moment. And then we're going to tackle the preamp, changing out the capacitors that are left over. There's a few transistors I want to change, and we may end up replacing some resistors also, trying to get it to the best that it is in the preamp section. And then the power amp is the last piece of the puzzle, and this amplifier is finished. All right, so I've got it all just patched together at the moment, put the power amp back in, just running it just to make sure everything still works. Got a 1-watt load. Distortion seems to have improved a tiny bit. That's sort of our reference point now. Now we're going to start diving into the preamp and just changing those last capacitors, some transistors, a few different things. Sort of go back and forward, see what improvements we get. But it is working still, so that is a good sign, I think. So let's get moving. So I just wanted to show you something. I was doing this board off camera because there's only 2 capacitors to change on this one and a couple of transistors here and here. But I was pulling this capacitor out and the polarity is marked backwards on the silk screening. It was installed this way, and I've confirmed this is the ground side and the ground is marked the other way. So I just wanted to mention that, and it just reinforces the fact, do not trust what it says on these boards on any amplifier, because they will screw you. Yeah, always do 1 cap at a time, mark them, or do something to keep track, because that is about your only thing you can rely on. You can never rely on the silk screen 100% of the time. So the preamp is all done. There wasn't much video to cover there. It was just a few capacitors and a couple of transistors to change. So we're going to dig into the power amp now. So this is going to be where the mountain of work is. So I'm just doing some health checks before we start, and I'm checking the DC offset on each channel. So the left channel is running 150 millivolts, that's too high. The right channel is running about 10 millivolts, which is fine. So I'm going to do this one a little bit different. I'm going to pull out the amp module. I'm going to take out the V-FETs, but what I'm going to do, because the amp module is basically split into a left and a right channel, I'm going to do just one side of it to start with. This is going to take me a long time. I'm going to do it off camera. I'm going to come back and then I'll do a time lapse for the other side once I know what I'm actually doing, because this is a mountain of work and it's not something I can time lapse easily because it's going to take place over many hours. The plan is we're going to change all the capacitors, the electrolytics. There's going to be some resistors that are going to be changed in the signal path, including all the ones that, you know, that just sort of just thrown in there at the moment. Most of the transistors are going to be changed also. The trim pots are being changed with high quality burns trim pots, and we'll see what else we can do while we're in there. So yeah, I'm going to just sort of jump forward and we'll have half of this done and we'll go over what's going to happen in the time lapse. Right, so we got half the amp module done. Everything is looking quite good. I've changed every transistor, every capacitor. I've changed a few resistors in the signal path. So I'm just running through some checks comparing the original right side to the completely rebuilt left side. Checking the sine wave at the gate that would normally go into the V-FETs. Just confirming that the gain is pretty similar and there's no issues with the sine wave. So just running it up through different frequencies, making sure there's no weird oscillations or anything. Checking to make sure I still have bias control through the bias pot, and that's all good. I haven't changed the bias pot yet. That'll get changed very shortly. But signal's looking pretty good. This is a slight gain variance between the original and the rebuilt channel, but that should all come good once we rebuild the other one also. So I've changed everything on the left side. This is reversed, so just keep that in mind. And I've picked out all the transistors already that are going in the right channel. I've tried to match them as closely as possible between the two, so hopefully we don't end up with any weird volume changes or other things going on. The differential amp on the left channel was really far out between the two, so that explains why there was a massive DC offset. So we've got to do the same on here. So I've gain matched those two between the differential amps really closely also, so they're almost identical between both sides, and all the others are quite close as I could get without spending hours looking through all the transistors. So yeah, everything's looking good. So I'm going to pull the amp module back out again, and then we've got to go through the whole thing, rebuild the right side, and then we are pretty much done. So everything is back together, board checks out, all my tests seem fine. Cleaned all the sockets, cleaned all the pins on the V-FETs, I even washed the screws in the ultrasonic cleaner. All traces of the thermal paste is gone. We're going to be using the new Berquist, however you say it, thermal pads. No more thermal paste. I love these things. Really good stuff, really clean. Yeah, so I'm going to throw this back in, get the amp board back in, do the bias again like we did in the first video, and let's see if this thing works. So here we are at the finish line. Everything is reassembled. This thing is just looking absolutely stunning. The amount of hours, weeks that have gone into this thing really pay off when you see it all come together. This probably has to be one of the best examples of this amplifier in the world, I would say. Not blowing my own trumpet, but it's just sheer amount of hours, and I've never seen one restored to this sort of level. I added some coupling capacitors across the main filter caps at the last minute. I didn't bother filming that because it wasn't really worth it, but they're just soldered onto those metal plates on the PCB. They're looking really good. I gave the transformer a repaint on the top because there was a big scratch in it. That's looking really good also. I need to bring it inside and warm it up properly to do the final bias adjustments, but you've seen me do that already in the first video, so we're not going to bother. The DC offset's looking really good. Left channel's running a lot better than the right, but we're still only talking 5 millivolts, so it isn't even worth mentioning. These two transistors at the top are what are responsible for the DC offset. I tried thermally coupling them together to see if it improved them even more, and it doesn't really make any difference, so I've just left them really close to each other just to make sure they track really well. But yeah, I was wondering what would finish this project up and make it just like the cherry on top, and I decided the last minute to make some new wood end cheeks to go on this unit, and they're looking really nice. This is just some wood I had lying around that had no home, and it's nice to put it to use. I'm not a woodworker. You know, I do a lot of different things, and I don't really have the end mills and the tooling to do wood really nicely, and I kept blowing out the cuts doing this. So these are not perfect by any means, and sort of a beta version. I would like to remake these now that I've learnt a few things and get some proper end mills for doing wood, but I still think they look really nice and they're going to go on. So I'm going to throw all this on and let's close this out. So that is it for this project. This thing looks absolutely stunning. I've completely washed down the faceplate. I put a bit of ceramic coating on it as well, just to bring back that original shine. Yeah, the whole thing from front to back is just looking amazing. I need to work on these wood cheeks a little bit more, I think. I shouldn't have used the original factory ones as my template because the factory ones are not a very good fit anyway. The carnage for this amplifier was significant. There's a lot that was changed here, a massive amount of work, and all the old RCAs and the binding posts as well. Before I close this out, just to let you know, there will be one final video with this thing where we benchmark it. I'm going to spend a week or two with it, just audition it, get my thoughts on it, and I'll do a review of that, like a final review. We'll benchmark it, we'll see its final power output, and just my overall impressions of this Sony V-FET TA-4650 amplifier. One other question, if people want to put in the comments, let me know if you do like seeing long time lapses of me rebuilding boards, or if you would prefer me to just jump ahead and show you what I have done and go over everything in detail rather than wasting all the time going through massive time lapses, because I have to speed them up so much that it's hard to see what's even happening, and I don't know what people prefer, to be honest. But if I slow them down much more, the videos are going to run for like over an hour. So I don't know what people prefer to see, and I tell you that recording time-lapsing is a massive amount of work. So yeah, let me know in the comments what you prefer to see in my videos going forward. And that's it for this amplifier. We'll be back in a couple of weeks for a final review. And until then, I will see you in the next video.